So, Marco from ST, thank you for. We are very excited to make this collaboration with Veecle, and we will explain here. Daniel will explain how they adapted this on ST M32 chips.
So hello everybody, so I'm Daniel, I'm co-founder of Veecle, a startup based in Berlin. First of all, thanks a lot for Marco and ST sponsoring us, right? So at Veecle, we deeply believe that in the future, AI will be writing most of the code that normally a human do, right? And especially for embedded system, we are trying to develop a platform where this will happen. So why are we doing that, right? I mean, when developing for embedded system, there is just an enormous amount of problems, right? But I mean, like, the fundamental one is that for doing anything at this point in time, you need a board, you need hardware often, right? So no matter how fancy is your workflow, you will always be as fast as your physical test can actually handle. So if you have one board and this needs to be shared by 10 people, you just do one person job, right? And when we started the company, we thought it was an operating system problem. It was a software problem, right? So we developed actually an embedded operating system, which we actually shipped on different vehicles. But while working on that, we realized it's really just a fundamental workflow problem, right? How do people develop, test, and validate software in automotive cannot be solved by just a new operating system, right? And while working on this, there was, you're probably aware, like the AI craziness, right? So in the meantime, it is clear, even if it's not now, within a few years, AI will write 90% of the code that humans now do. And, but what is important, it's very imperative to understand, if you ask Claude to write a website without tools, it will just write garbage, right? But the fact that it's able to test that website, validate that website, take a screenshot of that website, this is what actually makes the difference from a mock-up that doesn't work and actually a production website, right? And so our learning was, okay, I mean, we worked 4 years in automotive, right? We have an operating system. We know how actually stuff work. And so we adapted fundamentally what we were doing to create a platform to enable AI agents to do that, right? And so we developed Veecle Chip Lab, right? Which is fundamentally a cloud platform that gives agents the tools for being able to develop firmware and test that, right? And how does it work? It's relatively simple. It's a cloud platform, as I said, but it's very not invasive. It's just an MCP that you add to your local coding tools or your local cursor or your local workflows, right? Also as a normal tool. So you don't need to change anything of your workflow, right? But it fundamentally provides 3 major functionalities, right? One is be able to actually build and test your firmware in the clouds. So you don't need any hardware board connected, at least for 90% of your work, right? It's able to run simulation. So you can later simply say, test this drone firmware against like these 5 hours of video stream that we generated via NVIDIA or whatever. And what's more important, and this can be hosted within the company itself, so we don't get access to the IP, is able to learn over time common bugs, recurring patterns, what is working, what is not working, and therefore giving developers as much information as possible on what you need to do on that chip to make it work, right? Going a little bit deeper on the feature, I mean, this is a true example, right? But you can imagine you're building a motor controller on STM32, right? As a first step, you don't even need to test it, right? You can query your platform, which would actually look at all what you did and simply, given specification, internal documentation, knowledge of what is working and not, would be able to already tell you stuff is not working properly, right? And then your local agent can actually improve. Following that, right, like you can overnight run 10 million tests. I mean, it's a matter of budget versus time. You want it faster, you just run it faster, right? So you are developing a driver, just let it iterate overnight. Your local agent will run 10,000 tests every time against Veecle, and over time will this convert to actually a good implementation, if not a mock, a prototype, or whatever. And finally, this is very important, is the knowledge base, right? The compounding intelligence. Because we run firmware on virtual chips, we are actually able over time to learn what actually works, what doesn't work, what are the specs, what is the coding pattern, right? And because of that, we are fundamentally able to tell users this code will not work in the way you intended, or we predict there will be a buffer overflow here because we experienced this into 50 overruns, right? Or because we see that as a company pattern of your current firm, right? And this is very important because then it means like the more code you write within your company or within as a group of people, the more the system will become smarter and the faster you will be able to ship feature, right? Which is a must in nowadays society, otherwise you're out of business. Yeah, I mean, our platform is live, is free, right? It's a pay-per-use model or an enterprise model. I mean, we have a booth together with ST in the hall there. Again, it's a productivity tool to facilitate the development of embedded software. And yeah, that's it, I guess.